Hey guys, welcome back to another episode of the Spatial Web AI Podcast Knowledge Bank. Happy New Year. I'm your host, Denise Holt, and it's great to be on this side of the ascent into the year 2024 with all of you. It's a year that is promising to bring us some big breakthroughs in the world of AI that will be changing everything we know about computing on every fundamental level. And that is exactly the kind of content I discuss and write about on this podcast and in my blogs. So be sure to subscribe to any of the various channels that I syndicate out to. I try to meet you guys where you're at, where it's easy. So you can find this podcast on YouTube, Spotify, and really all other podcast streaming channels. I publish my writing to my website blog, which is deniseholt.us, and I also syndicate it out on Hacker Noon, Medium, my LinkedIn newsletter, and now I also have a Substack under my name, Denise Holt. So please subscribe wherever you prefer reading. I'm actually really excited about my Substack because it gives me a place where I can engage with and reward you guys as my earliest and most loyal audience members by offering some really cool extras on there as well. So if you're a reader on Substack, be sure to subscribe to my channel there so you get the most out of tuning into my content. And as I mentioned in my last Knowledge Bank episode, I'm still wrapping up the audio reads of my last few articles of 2023. And this one today is titled Unlocking the Future of AI, Active Inference versus LLMs. So let's get started. The world versus words. In a world where AI reigns supreme, there is a question looming among the tech elite. Are we on the cusp of true intelligence, or are we merely toying with sophisticated text generators? As we marvel at the prowess of large language models, LLMs, like ChatGPT, Claude, and others, it's time to investigate a bit further and seek answers. Beyond the hype and fascination lies a catalyst for change and remarkable innovation, fundamentally redefining what AI means. Active Inference AI. What sets these two approaches apart? And why might active inference hold the keys to AI's future? Join me on a voyage through the complexity of these groundbreaking technologies as we eliminate confusion and reveal a path that leads to more than just enlightened conversation. It leads to a new era of AI built on the very foundations of human intelligence. Two roads diverged in a wood. The rise of large language models, LLMs, like OpenAI's ChatGPT, has stirred endless excitement and curiosity about the capabilities of artificial intelligence. These systems have the remarkable ability to generate human-like text and engage in diverse conversations, fueling expectations for AI's future. However, as impressive as LLMs are, they have inherent limitations when compared to this new revolutionary approach to artificial intelligence, known as active inference. Let's dive into the fundamental differences between LLMs and active inference and why the latter is positioned to emerge as a vanguard of the future of AI. Limitations of LLMs: content creation versus real-world operations. LLMs are powered by deep learning on massive data sets, allowing them to recognize linguistic patterns attuned to various subject matter and generate outputs that seem coherent. However, this statistical pattern matching does not equate to true intelligence or understanding of the world. LLMs fall short in several critical aspects. 1. Contextual awareness. LLMs lack the ability to actively perceive or reason about real-world situations as they unfold. Their operation solely depends on the data they were trained on, devoid of any real-time sensory input. 2. Explainability. Understanding the decision-making processes of LLMs is an elusive challenge. Their outputs are essentially probabilistic guesses, even if fluently phrased. 3. Grounding in reality. They hallucinate or fabricate responses outside their training distribution, unconstrained by real-world knowledge, blurring the line between fact and fabrication. 4. Ability to take action. LLMs cannot act on their environment or test hypotheses through exploring the world. They are passive systems. So these deficiencies make LLMs poorly suited for most real-world applications, especially those requiring nuanced situational understanding or the ability to operate autonomously in dynamic physical environments. Their strengths lie more in generating content, ideas, and prose based on recognizing patterns in immense data sets. In fact, a recent paper by Google provides evidence that transformers, GPT, etc., are unable to generate beyond their training data. Quote, "We find strong evidence that the model can perform model selection among pre-trained function classes during in-context learning at a little extra statistical cost, but limited evidence that the model's in-context learning behavior is capable of generalizing beyond their pre-training data." End quote. The paradigm shift. Active inference, the future of AI. Active inference, based on the free energy principle developed by Dr. Karl J. Friston, world-renowned neuroscientist and chief scientist at Versus AI, represents a paradigm shift in AI. Active Inference AI is modeled after how the human brain and biological systems work. Through this method, an intelligent agent is able to continuously sense its environment, take action in real time based on that sensory input, and update its internal model of the world, just like humans do. This sets it apart from other AI approaches that are static and cannot adapt and evolve in real time. Active inference has the capability to start off at a basic level and rapidly evolve in intelligence over time, similar to how a human child develops. This positions it to continuously improve and adapt as it accumulates more experiences and knowledge, making it far more advanced than current AI. Active inference also possesses two unique capabilities. Human laws and guidelines can be programmed into these systems, and they will abide by them in real time. And these autonomous systems are also capable of introspection. They can report on their own processing and decisions, making them completely auditable. This gives them an unparalleled advantage in being able to grow and evolve in collaboration and cooperation alongside humans. In contrast to deep learning, active inference is founded on principles of embodied cognition and Bayesian inference, delivering several key attributes. Active inference as embodied AI. Sensory integration and real-time interaction. Active inference AI mimics human abilities to sense, perceive, and interact with the world in real time. It can see, hear, touch, and respond to environmental stimuli, similar to human sensory processing. World modeling and decision making. This AI continuously updates its world model, akin to how humans learn and adapt. This evolving understanding allows it to engage in complex decision making and problem solving tasks. Planetary management and support. Active Inference AI's capabilities extend to managing large-scale systems like climate, biodiversity, and energy flows. It is envisioned to support and protect every individual and living entity on the planet, much like a global caretaker. Unique advantages and benefits. adaptability, and evolution. Unlike traditional AI, Active Inference AI evolves continually. It's self-evolving, self-organizing, and self-optimizing, aligning with the concepts of autopoiesis, a system capable of reproducing and maintaining itself. Comprehensive application spectrum. The AI's capability extends far beyond current AI applications. It can address real-time updating and adaptable scenarios, making it ideal for complex tasks like running supply chains or smart cities. Holistic integration. The technology is seen as bringing the planet to life, integrating the digital and physical worlds and transforming the planet into a digital organism. This holistic approach signifies a major leap in AI capabilities. This manifests a new type of AI that is capable of perpetual learning. Active inference agents continually update their beliefs by interacting with the world in real time, integrating new observations into their internal model of how the world works. Contextual awareness. By gathering multi-sensory input, agents build a dynamic understanding of unfolding situations, enabling complex reasoning and planning. Embodiment. Agents learn faster and perform better when they are embodied in simulated or physical forms, allowing them to test hypotheses through action. Explainability. An agent's beliefs, desires, and decision-making processes are transparent and grounded in its observations and prior knowledge. Flexible cognition. Active inference agents can seamlessly transfer knowledge across diverse contexts and challenges, similar to human adaptability. These attributes make active inference a groundbreaking approach to AI. But what takes it beyond the horizon is the integration with the universal network of the spatial web. The spatial web, the framework for distributed and multi-scale intelligence. Active inference's potential is amplified when it converges with the spatial web protocol, HSTP, Hyperspace Transaction Protocol, and HSML, Hyperspace Modeling Language. This convergence unleashes a distributed form of active inference and fosters collective intelligence among multitudes of intelligent agents. HSTP, the backbone of distributed active inference. At the core of this integration is HSTP, the Hyperspace Transaction Protocol, serving as the digital nervous system. It enables seamless communication and data exchange among various technologies, sensors, machines, and intelligent agents, unifying them on a common network, creating a dynamic, real-time ecosystem. HSTP captures real-time data from multiple sources, forging a comprehensive contextual understanding of any given situation, much like the human nervous system. HSML, the lingua franca of the spatial web. HSML, the hyperspace modeling language, plays a pivotal role in this orchestration. It's not just a language, it's the bridge between diverse technologies and agents in the spatial web. By programming context into the digital twin spaces of every element in the world, HSML creates a unifying layer that resonates across the entire network. HSML acts as the translator in a multilingual conversation, ensuring every technology, sensor, machine, and intelligent agent can comprehend and communicate effectively. The world model, a living, breathing entity. This ingenious amalgamation of active inference with HSTP and HSML gives birth to a comprehensive world model, providing an evolutionary path to AGI and beyond. This world model is not a statistic representation. It is a living, breathing entity that continuously adapts and evolves in real time. It's the digital twin of the real world, reflecting the ever-changing dynamics, interactions, and complexities of the environment it models. With HSTP and HSML, the world model acquires a depth of understanding that transcends the capabilities of traditional AI models. It gains the ability to perceive, reason, and adapt to real-time events with unparalleled accuracy. It becomes the foundation for all perception, decision-making, and action within the AI system. In essence, smart cities will function like a digital organism, paralleling the human body's brain and nervous system. They utilize a dynamic holographic world model, constantly updated by real-time sensor data, analogous to sensory neurons. This model represents various aspects of the city, climate, or other environments, and is linked to the Internet of Things, which includes drones, robots, and automated systems. These elements act like motor neurons, executing changes in the physical world. The sensory network then updates the world model based on these changes, creating a feedback loop. This process depicts the evolution of intelligence, where the system continuously refines its understanding and interaction with the world, reducing surprises through accurate inferences from the current world model. The free energy principle provides the mathematical framework for this evolutionary process. While natural selection explains the evolution of physical bodies in animals, the evolution of world models can be considered a branch of memetics, similar to genetics, but not biologically based. The free energy principle provides us with the mathematics of evolution of intelligence in these complex, interconnected systems. AI that is capable of governance. The explainability of active inference AI, the ability of self-introspection and self-reporting, coupled with the use of HSML, where human laws can be made programmable, enabling AI to understand and comply with them in real time, offers a solution where the development and implementation of trustworthy and governable AI systems prevail. In July 2023, Versus AI, along with Denton's law firm and the Spatial Web Foundation, published a groundbreaking industry report titled The Future of Global AI Governance, establishing frameworks for ethical, robust, and lawful AI. These frameworks refer to successful proofs of concept using active inference AI and the Spatial Web Protocol, HSTP and HSML, demonstrating remarkable success in programming AI to comply with human laws, integrating various AIs into a larger governable network. This report affirms the importance of regulation standards and proposes categorizing AI into different levels of intelligence and capabilities for appropriate governance methods. The overarching theme is to use these technologies to govern the autonomous systems themselves to ensure responsible and effective governance of AI for safety, privacy, and ethical use. The act of correcting a machine occurs within the code, and through these technological breakthroughs, Versus has developed a way to do that. Real-world impact, active inferences applications. The distinct capabilities of active inference find applications across a myriad of domains where situational awareness, adaptability, and autonomy are paramount. Robotics, enabling control of autonomous robots and vehicles operating in dynamic real-world environments from factories to homes and automobiles to drones. Logistics, optimizing delivery drones and coordinating swarms for safe and efficient navigation. Healthcare, personalized care through smart beds, wearables, and assistive robots for patient monitoring. Smart cities, managing critical systems including hospitals, airports, supply chains, traffic flows, public services, and infrastructure through distributed networks. Finance, detecting fraud, risk, and anomalies in transactions in real time. Scientific discovery, streamlining processes such as materials development, drug discovery, and particle physics. In contrast to current LLMs, which remain narrow, passive, and bound by static training data, active inference represents a developmental approach to AI characterized by embodiment, context, dynamism. While LLMs excel in content creation, active inference holds the next evolution of AI that can grapple with the complexities of the real world. As the development of this technology matures, it promises to revolutionize AI integration across domains, from robotics to finance and scientific discovery. A new era of AI. In the realm of AI, where understanding, perception, and adaptability are paramount, the convergence of active inference with the Spatial Web Protocol, HSTP and HSML, is the catalyst of transformation. It ushers in a new era where AI transcends boundaries and limitations, where it possesses the contextual world model essential for true intelligence and the cultivation and expansion of universal knowledge. Words versus the world. Large language models have captured the imagination of the public regarding AI's potential, but they face significant limitations compared to the emerging implementation of active inference. Active inference's continuous interaction and learning model lead to more flexible, context-aware intelligence. Active inference agents excel at understanding nuanced situations, adapting to new environments, and operating autonomously in the real world. While LLMs are ideal for content generation, active inference paves the way for AI to navigate the complexities of real-world challenges. As this new paradigm advances, it will drive innovation and automation across an array of fields, transforming the landscape of AI applications. Versus AI's position as a global AI leader. Versus is fundamentally redefining what AI means, moving toward a model that is more akin to natural intelligence. They are the only company pursuing active inference AI based on the pioneering work of Professor Karl Friston, Versus chief scientist. This gives Versus a huge competitive edge, as active inference allows for true embodied AI that can power general intelligence across countless applications. No other approach comes close to the flexibility and advancement of active inference. By being self-evolving, self-organizing, and autopoietic, self-generating, active inference AI will grow rapidly in the capabilities and use cases. Over time, it is expected to surpass the abilities of current AI like LLMs and enable new applications not possible today. This has the potential to bring about major breakthroughs in AI and allow Versus to establish itself as a leader. The company's strategy mirrors significant technological shifts in history, such as the transition from BlackBerry to iPhone. The development and adoption of active inference AI represents a paradigm shift in AI, capable of unlocking new possibilities for AI to positively impact humanity, with applications ranging from digital assistance to smart city infrastructure optimization and beyond. This positions Versus at the forefront of the next era of AI advancement. This new framework, spearheaded by Versus AI, opens the door to a future where AI seamlessly integrates into our lives and society, guiding us through the complexities of the real world with finesse and precision, able to handle mission-critical operations with the potential to assist in large-scale planetary and humanitarian crises. The union of active inference and the spatial web isn't just about AI evolution. It's about revolutionizing the way we interact with technology and the world around us. It's a paradigm shift that promises to transform AI from a tool into a true companion in our complex, ever-changing world. You can learn more about the advancements with the spatial web at spatialwebfoundation.org or visit verses.ai to stay up to date with Genius and Dr. Karl Friston's revolutionary work with Verses in the field of active inference AI and the free energy principle. And be sure to subscribe to my blog and subscribe to this podcast, where I strive to take these complex topics and make them easy to understand. So thanks again for tuning in, and we'll see you next time.